By the end of this meeting, we not do this. Guaranteed. Okay, so the next panel is really interesting to me. I really enjoyed being part of this effort with NIST. Our moderator today is Ray Ivie, and I've worked with Ray for 3 years now, I guess. But when I started to write up his intro, I had no idea. Somebody stopped me. What had Ray not done? Ray was a Navy pilot and flew over 2,500 flight hours and 686 carrier landings, and commanded an SWB squadron. He held several senior executive positions in a variety of military contractors who focused on C4ISR, very close to what we're doing here. So very broad experience in telecommunications, technology, innovation, intelligence, DoD, and Homeland Security communities. Currently, he serves as the director at TEEX for Testing and Innovation, the Testing and Innovation Center. And they assess technologies, conduct problem-solving summits, facilitate research for first responders and Homeland Security and public safety communities. So really happy to have Ray with us today.
Thanks. All right, I'll try. Howdy. Howdy. Sing it louder. There you go. So how many of you live in a town or a city that has cameras on the stoplights and other sensors around them? They may not use them for, like in Texas, they're not allowed to use them for tickets, but they can use them for forensics and stuff like that. So most people do that, okay? So how many of you have some type of sensor in your home, a ring camera, a blink, a Nest thermostat, smart refrigerator, whatever? Not as many, okay? Well, imagine if we had a major disaster. And as responders are going toward that disaster, let's say Galveston, major hurricane, they could see, using the smart city sensors that are in place and the IoT sensors that are in place, maybe in your homes, if they could see what's going on before they got there, and if they could tap into some of those sensors and see that maybe there's a fire, maybe there's someone screaming, and a ring camera audio, infrared system. If they were able to utilize some of that sensor data, then they could prioritize where they went and what they needed to do when they got there. Now, there's a whole other privacy and policy issue there, right? But what we set out with AI3 and NIST sponsored AI3 to do was specifically that. See if you could bring together sensor data from smart city sensors as well as IoT sensors, pull those together in an intelligent way using AI, and then display that for first responders. And that's exactly what we did during the AI3 challenge. So we're lucky today that we have a lot of the people that participated in that challenge. And we'll start out first with Allison Kahn, who is the NIST sponsor and project lead for first responder personal area network research. Wait.
Hi, everybody.
Then we have PG Ravindran, and I told you. She was a judge for Qualcomm. Qualcomm was leader in developing and building semiconductor software services for wireless technologies. And we have Tommy
You did all right. I'll give you 50%.
50%, okay. I speak tech. From Zebra Technologies, working with Qualcomm to power remote and interoperable solutions through mobile computers and tablets. And then last but not least, we have winners. So in this competition, we had 2 first place winning teams. One team was John Chrisman and Godfrey Nolan from CNA in Greece. And the other team was Bethel Quick, David Ganesh from Engineering Dynamics. So anyone want to say anything else about themselves? A humble group.
Very humble.
A humble group. All right. So to kick this off, I want to start with Allison. And ask Allison, this response to the previous challenge is similar to this one. What made this one so different?
Thanks so much, Ray. I know a lot of you have been involved with PSCR in one way or another over the past few years, and we have held a lot of prize challenges that tapped into IoT and sensor data, such as the Chariot Challenge and Commanding Tech. And in those challenges, we've really been focused on how the first responders ingest and react to that sensor data once it's been displayed on some type of device, whether it's their mobile device or an augmented reality device or something of that nature. And so we really focused on the first responder interface. For AI3, which is the Artificial Intelligence for IoT Information Challenge, we wanted to focus a layer back on how we can really optimize getting that information to the first responders and then having them react to it. And I was very happy to see the information on ISF come up before this, because it just so gracefully lays out the three kind of levels of how first responders, receive, ingest, and react to data. And so we were kind of focused on that middle layer, and seeing if AI could be the technology that could really overcome like having to do all these system engineering on the fly and things of that nature. So that was the challenge that we put out in our cooperative agreement, and eventually Texas A&M responded to it. And the proposal they came up with was just so great, because they were able to incorporate just such a diverse environment like Disaster City to create this sensor test bed, which would provide the foundation for AI3. So I think that this really kind of took this previous work back a level and started understanding how the communications could be optimized and then brought to the first responder.
Great, thanks. So let's go to the winners, and we'll start with engineering dynamics. What was your solution, and what were some of the big challenges you faced and had to overcome?
So we obviously used AI to integrate, or we used an algorithm that helped us decipher unknown data. And we were able to, given that IoT data is so new, we had a really hard time figuring out how to determine what data was what. And so we ultimately ended up using synthetic data in order to model A equals A and B equals B. So with this information coming in, we knew that it was a vibration sensor. With this information coming in, we knew that it was a heart rate sensor, and so challenges were the data changing on us. That's always a fun challenge. But that doesn't provide them. So is that pretty much? Yeah.
So Godfrey, John at the end.
Okay, so what we did was pretty close to what the ISCF does. It's the classic presentation, middleware, and then database layer. So we have a pretty simple way of, well, we thought it was a pretty simple way of changing the IoT data, but when we actually saw what we got, it didn't work out quite that well. The presentation layer we used ATEC, so that was, which was an earlier presentation, so I feel like I have a foot in almost every session today, which is great. But the challenge was, the data change. And the challenge was also trying to find the IoT data. So just examples of the data that's out there. So, there's such a huge, vast range of IoT sensors out there. Trying to get some representative data is problematic.
Yeah, and I can, hello? You want this? And I can add to that. our solution that came out of this competition is called FRAME, First Responders Awareness Monitoring during Emergencies. And so our solution heavily uses tech for the presentation layer. And our goal is to, and this is still an ongoing project, and our goal is to provide, have an application that takes all of this IoT data that's out there during an emergency and synthesizes it and analyzes it in a way that makes it usable and easy to use for first responders, first responder commanders in the community. So one thing we're doing is that, well, first of all, we don't want to reinvent the wheel. If there are TAC extensions of features that already exist, let's use those. But also we're looking at open source AI models for various things like object detection, sentiment analysis, and if needed, we want to apply transfer learning, which is when you take an AI model that is purposed for one thing and you engineer it in a way so it'll be purposed for this other task. So as long as the tasks are related, so we plan on doing fine tuning on these models, which is where you take a model that was trained on one task, you freeze its parameters, or you initialize its parameters in a certain way, and you use like a small data set for your new task, and then you retrain it for the new task. So these are things that we're looking into.
So with all the different types of formats, and in many cases, we didn't tell you exactly what type of sensor it was.
No.
How can you tell what it was and what you could get from it? Go ahead, John, you got the mic or that's what you did?
Yeah, sure. So, for the competition, we were given, one feature, which was the numeric values, and we had to determine what the IoT device was from that. So I guess, it depends on, the distribution of the data for each of the IoT devices. The machine learning models, for this competition, it did not perform that well. So, in a real world situation, we'd have to do some rescoping on how to make this work better for the future.
I just add a little bit that the competition itself was really felt like one of those hacker competitions, the ones that they do over a weekend, where you were trying your best to get all the information processed as quickly as possible. And then I know that one of the things that I didn't want to talk about was lessons learned. So lessons learned for anybody who enters these competitions in the future would be to get us really focused on getting as much data as you can, and just to be able to see as much different data, because on the day it's pretty difficult to be able to figure out what a pressure monitor is if you've never seen what the data is.
One thing I would definitely add is that AI, as with human learning, has a lot of similarities. You can look at data trends. You can look at the slope of data, how fast it's changing. You can look at the ranges. This is not our first competition, so we figured that there would be some sort of trick. There was. So there was a carbon monoxide sensor, whereas previously the only discussion had been dioxide, I believe. Yeah. And the slope was about the same, but the range was entirely different. And so we could look at things and say, okay, this is probably a gas. What other things would be in a fire environment? Okay, hey, there's a missing piece. So a lot of AI is not just computers, it's using common sense to add in ground rules to help guide in the direction you want to go.
So, okay, you got the mic. So not all of your sensors had geospatial information. How did you deal with that?
So again, because there's not a lot, the problem with IoT data is it's brand new, right? It's still a brand new technology, and ultimately, we are, using my hands, I'm gonna spill tea all over the place, and we start that. So ultimately, what's happening is there's no generalized, generalized baseline. We don't necessarily know how to interpret the data from one brand to the other. So essentially what we did was we created an algorithmic model that was able to interpret, given the slopes, given the models, how, and basically plug it into a box. Okay, this is close enough here, so it can go into this bin, it can go into this bin. And again, that common sense, we were able to determine further on. So for example, the carbon monoxide, there was, it was steady, 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 and then there was a spike. And so given what we know about sensors, given what we know about the availability of sensor information, we were able to determine that the gas was carbon monoxide rather than carbon dioxide. I'm missing something there. Geospatial, that's something.
They did a really solid job with the data such that like everything was had the same time scale. So we were able to kind of follow the data and get a pretty good idea of what was happening. So even for those pieces without geospatial information, we were able to say, okay, there's a Fitbit. It looks an awful lot like a firefighter is entering a burning building. And we were able to construct the whole piece, even though there was missing pieces. And in the real world, there's going to be missing pieces. There's going to be data that's corrupted. There's going to be data that's just flat out wrong.
Absolutely, right? So CNA and Greece used ATAC as their visualization platform. What did you use?
Just the basic visualization. There's a bunch of programs out there, but we just use the standard plot.
Yeah.
I think one of the reasons why they split the prize was because you guys did way better on identifying each of the IoT sensors, and then what we did was if we put the two things together, we had a great way of showing what it was at ATEC, because it's pretty obvious what the different sensors are, where they're placed. So I think I'm guessing that's why in the end we ended up split.
Yeah, that's how I remember.
Oh yeah, we asked the judge.
Unfortunately, I'm representing the other judges too, but we were three of us and we were given one job to judge the competition, and out of the four, we picked two winners. So there you go in terms of decision making. But but the reasons that we came up with two winners is one is definitely in terms of say engineering dynamics. They did describe some of their unique attributes that they contributed to this competition. But it was more about the synthetic data generation and how they went about using existing data, but then creating an opportunity to create some artificial data using GAN networks and so on, using some of the AI principles, and being able to then identify some unknown sensors. The reason this is important is, yes, given a situation, even if it is happening in a smart city, you don't know the types of sensors that are going to be embedded and the ones that will be brought in. And you will not be able to decipher the overall situational awareness effectively without it. And generally, the synthetic data generation has many of that, especially with Gen AI. So that was one of the building factors. The CNA is definitely, it was a comprehensive system design end-to-end. It was well thought out across the layers. And fundamentally, it could interoperate and integrate with the approach, as you saw earlier today with the TAC presentation. Utilizing open source tools and open interfaces allows for that expansion of capability and scalability of the solution. And that was one of the major aspects. One comment I would like to make is I would like to see more on-device analytics and on-device AI.
So Tommy, how's the technology impacting the industry, the AI technology that is? And what opportunities and challenges do you see going forward?
Yeah, so I think like we're seeing with this challenge is there's so many sources of data out there that are useful if they can be analyzed and interpreted in a way that it makes sense. So the way I see AI coming in is we've got all this, sensor data, video surveillance, shot spotters, basically all kinds of data exist that if there is a way, and through some of the challenges and innovation, AI can analyze it and make it presentable. So talking about the presentation layer in a format that it makes sense for first responders and other agencies responding to disasters or in charge of public safety can make sense of that data and use it to make informed decisions in how they respond to the disaster. The other thing that Vijay touched on, which is kind of what kind of ties us together at the hip, is all of the things we're talking about AI analytics, we're assuming there's connectivity and we can get to the cloud and all that stuff can be pushed back and forth. But the truth is, in a disaster, there's either no network resources or very limited network resources. And you have to make do with what you have, which is your device, right? So how much of that analytics, how much of that intelligence can happen on the device and still make AI usable in a way that it's functional and useful for emergency response. So just some things to think about is all this stuff is great, but when there's limited resources, no connectivity, how can we do as much as we can with what we have at hand, which would be your device?
Okay. Godfrey, how do you see, as you arrive into a disaster area, you're trying to see what's there, maybe beforehand, but then everyone rolls in with new communications and all these other devices. Have you thought about how you might separate those out to what was brought in and what was already there?
How would you filter it? Is that what you mean?
How would you filter it? How would you visualize it?
Well, I think that's one of the things that ATAC does pretty well, is to be able to give you kind of the situational awareness of everything that's going on, plus allowing lots of people to connect into devices, plus you can, depending on how you design the plugin, filter out whatever data you want based on, what the agency is, what the first responder type is, what the sensor is, that kind of thing. I did want to say though that the project that we've done continues to live. It's not like we did a competition and it's done. We're also using it for another competition for DOT. We're also using it for potentially, we're trying to pull in some remote idea. We're talking to a partner who's got remote information from a device that they built, which I think would be pretty useful. Currently, we're in Miami. There's lots of drones flying in Miami for whatever reason. And we're also trying to just add more sensors. And then I believe there's a competition coming up next year. We could probably use the same thing, which is great. And hopefully by the end of the summer, we'll be able to publish our ATAC plugin. That's the plan.
So David and Bethel, you pulled out the signals from over the air for this, or you were given simulated signals. How would you deal with it? And most IoT sensors are not, they're encrypted, so you're not going to be able to just pull it out of the air. How are you going to deal, or how do you see dealing with a service company like a Ring or a Link service or something like that to getting the data?
So this is something we've thought entirely too much about. If you're in an emergency situation, you do not want to be in the world where you're trying to find Bob, who is the only guy with the password to the service. So you have to set up these partnerships ahead of time. You have to set up the infrastructure, and you have to also consider the privacy of it, like we were talking about earlier. You need to be able to, in an emergency, immediately get access to all the data that you need. But outside of an emergency, you also want to have probably some sort of logging such that it can't be used for nefarious purposes.
We don't want Joe Blow, Leo over here being able to access the system 3 months later and spy on the next role, right? So.
As with everything, there is a fine line, right? I think my answer is policy. We are kind of at the forefront of technology. We're trying to figure out what can be used. But the actual answer is going to be the Congress and state and federal, like, we need to have policy in place that will guide the implementation of this. And we can promote excitement, we can show what's possible, but it's not on us to figure out how it can be used.
So that brings it over to the whole nest. So Allison, there's a challenge for you. How do you help policymakers understand what you're trying to do?
Well, PSCR has a rule, we stay away from policy, but, and I mean, at least in the federal government as a whole, I mean, everyone is trying to understand how to wrap their heads around artificial intelligence and what the boundaries should be, what the risks are, what the ethics are, and what bias is. I know NIST has several roles in that, not through my particular laboratory, which focuses on communications, but the Information Technology Laboratory heads up the National Artificial Intelligence Advisory Council, which reports directly to President Biden on different issues surrounding artificial intelligence and technology surrounding it. NIST is also playing a big part in the recent executive order. I think it was 14110 on the safe, secure, and transparent artificial intelligence, which is very important towards just evaluating artificial intelligence technologies, making sure that we're using them responsibly and that we're securing them accurately, and bad actors, you know, cannot get as much access to it. But as Dave and Bethel and everyone has reiterated during this panel, I mean, it's just such a new technology. What we're dealing with is just the very tip of the iceberg of artificial intelligence technologies that are out there. So the government's trying.
So a little easier one for NIST. What about standards?
That's the easier one.
Standards, that's what NIST is all about.
Yeah, I'm sorry, from a PSCR level, I'm really unsure of what artificial intelligence standards are being proposed out there. Does anyone have any?
So two comments, one on the policy matters and that needs to govern the exchange of information or the necessary levels of information sharing. So to that point, again, on the on-device AI aspect, one of the major advantages, apart from being able to have your real-time responses out of your sensing information, it's also about preserving privacy, because your raw data does not have to be transmitted anywhere, it does not have to leave your device. It's also the personalization. It's putting your data, your device's data in context of everything else that's going on around it. What is its location? What are other devices it's connected to? Is it at home? There's a lot of contextualization that comes with on-device AI that you will not get with clouding. When you ship raw data out, you don't know a lot of the coordinates, for example. But if you're locally processing it, you have the benefit of contextualization, privacy, cost reduction too, in terms of all of that processing can be centralized, can be distributed. And what that now allows, and that is essentially what's going on in the commercial, especially the beginning with enterprise, House Copilot, for example, Microsoft Copilot can activate on-device data. It's going to convert what you have as raw context, raw information into intelligence. And now the intelligence is abstracted, you can then facilitate sharing across different stakeholders and stakeholder agencies. So there are several advantages to how you would apply on-device AI. And to the second point, in terms of AI standards and AI security standards, there are definitely a lot of AI standards and there's de facto standards in how even the generative AI large language models are being generated. But with respect to AI security, it's very nascent. The field is very nascent with respect to responsible AI. Yes, NIST has a risk management framework. But in terms of the global AI security standards, there are some activities going on, primarily from a privacy perspective, and safety perspective, safety, not just autonomous driving, but also personal safety. So that's where the industry is as far as we can tell.
So the greatest, sensor, interoperable sensor ever created is probably the cell phone. Right? And we all, I think pretty much everyone here is one. So Tommy, where do you see trying to do more with a cell phone and making it interoperable to across the spectrum and across other sensor sets?
So I think that from a device standpoint, like VG was saying, is having as much that can be done on devices, be done on devices as much as possible. I talked about network resources, being limited in emergencies, but keeping things local kind of, addresses to a certain extent on those security concerns. And keeping it local on the device, cell phone, tablet, whatever it may be, allows it to be such that the data that's being leveraged by AI or being leveraged in this network is relative to either the incident that's happening around that device or the person that's leveraging the device to do something, again, localized to where that device is located. So I think that's sort of, where the using what you have on hand to do as much as you can. It really does kind of create not a bubble, but it creates a more isolated incident where a lot of the challenges and concerns around privacy, where my data going, looking at my video, blah, 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 gets a bit more limited. And I think maybe that's sort of where from the device and OEM standpoint, we should maybe do a lot more with kind of what we offer that helps address some of these concerns.
Would that be like a geofencing type?
Yeah, something like that, yeah. That kind of controls what's happening, again, around that device and what data is being leveraged.
Okay. So, VG, you deal with all the suppliers out there. What's something that manufacturers could do to improve sharing of data, or at least sharing some type of format or standards that they could be more interoperable?
Question. Fundamentally, our approach has always been enabling the ecosystem. So from that perspective, a lot comes down to how open the interfaces are or how acknowledged the interfaces are. They may not all be standardized interfaces. At the very lowest level with respect to air interface, like the cellular standards, there's interoperability that is achieved through the standards and through the verification, the compliance and certification that goes along with the implementations that verifies that interoperability occurs. That's why your phone works all over the world, with an international plan. So a lot of rigor goes into that air interface, but then above that, the application creation is done over a platform such as an operating system. So the operating system facilitates the APIs underneath on a platform like a chipset and exposes those APIs to open APIs to OEMs, device manufacturers, to start building their devices and enabling the interfaces for network operators, for example, to manage and provision and secure the device. On top of it, then there comes the applications, the actual applications and services that get defined. And there again, it's based off of these open APIs. That's what facilitates, reduces the risk in the market, reduces the cost of deployment, and ensures interoperability and a thriving ecosystem and a market. And that's what the commercial world does. And in terms of facilitating a more uniform data management or data integration across different types of devices, including ASMs, or Zebra, what are the fundamental feature sets that are being drawn from the chipset, from the OS, though that data is still available. It's just the format that the OEMs present that data to. In terms of data unification, there are some standards defined. There's an old compliance standard that is defined to facilitate that integration. But there are things that can be done. One of them, for example, in public safety, we've seen TAC is a great example. It's an open interface. It allows for some of the underlying capabilities on the chipset to be presented to the user as well. We've heard a lot about the various use cases of TAC, being able to visualize, providing this common operating picture, providing an open interface that anybody could use across platforms, across Android or Windows or iPhones, iOS. But in addition to that, what we realized as chipset vendors is there's a lot of capability underneath that is not being utilized by OEM. So there's a lot to do with education. So, you know, as Tomi said, we're kind of ahead. That is information sharing of what are the relevant features for public safety that can be utilized. I can talk about a couple of them. One is the detection of rogue base stations, for example. That feature set has existed on the chipset for a very long time. It has not been used even in DC, for example, where the embassies have rogue base stations. It has not been utilized. But that's something that we are educating the public safety sector of the OEMs on how to utilize it. We have used TAC, for example, to expose that feature, create a threat zone, and so on. So that's just one example of how you can unify and how you can improve the level of capability that can be possible for public safety.
Okay, thanks. So let's open the floor to questions.
I assume that some of the sensors y'all were addressing information from were either acoustic or potential field kind of data. And from what your comments were about the slope and rate, you were probably looking at something that would be more alertable in a public safety format. Oh, here's a spike in the data. Okay. Were you looking at anything which had a more steady state kind of approach to the of data where you're looking at something that has some variation to it, but doesn't really spike, but you're looking for other kinds of changes in that data?
I believe one of the sensors was wind speed.
Okay.
That one very valuable in, you know, especially a fire scenario where, you know, dramatically affects everything. Not really huge spike, but definitely a valuable component. I think we also had RMS sensors measuring like accelerometers measuring earthquake type scenarios. That's let's see what else did they have.
There was also, I think the code was fitness. We coded it as like a wearable.
Yeah.
But that I think could go either way. It could have that regular, but in certain cases it could also spike as well, right? So if you're looking at something like heart rate or SpO2, a spike in heart rate isn't necessarily an indicator of a problem unless there's also an additional component. And so I think we factored that in sometimes too, but I think it was the atmospheric. There was also air quality, I believe.
So were y'all cross-mapping any of the data from these various sensors then as part of your approach?
Yeah, and I'm assuming you guys were doing the same, but we were trying to form a comprehensive picture using limited scraps of data.
Okay.
And in a real world scenario, I would hope we would have a lot more sensors, be able to form an even better picture. But we had what, I think 16 data points, 18.
Real, and then you had simulators too.
Yeah, so, and it's not a lot, but it was enough to get a really good idea of what's going on because we were able to use our model to make assumptions, and those assumptions tended to be backed up by the new data that we were discovering.
So were any of y'all familiar with various sciences that were involved in it, you know, geoscience or meteorology, or were y'all all into the AI kind of end of the equation and you're just smart enough to figure this stuff out?
I think to some extent, we did find some things just by process of elimination, by common sense, right? The carbon monoxide was a perfect example of that. Watching, but we have a similar solution where we actually use, multiple axes so for example, the wearables, right? When we're looking at the SpO2 and we're looking at the heart rate, if one spikes, but the other one doesn't change so much, we're not really concerned. But if both of them change, erratically, then hey, we maybe need to monitor that first responder, right? So I think it's a combination of all of it. I think it's a combination of the human component, which is massive. And it's also a combination, adding that in with the technology and how to best use the technology, and ease of use with that human factor, because the humans are the problem, right? In all of this, the humans are the problem. So by factoring those things in together, I think we got a pretty clear picture.
I think I would add slightly, our logo is engineering is a people problem. So often, and you all know engineers will come up with this beautiful solution and it's so cool and it doesn't actually meet the core needs, so it gets shelved on a shelf somewhere and no one ever uses it and it takes valuable money. We believe that you have to look at that core problem, what the user's actual problem is and what will solve that problem.
Outstanding. Held it outstanding.
Up to the other side, John, you know.
Other questions? So, John, are y'all showing anything on Thursday? Yes, sir. Are we showing anything on Thursday? Are you actively, David, or no?
I didn't. Yeah, we could absolutely put something together, but I don't. We're told that we were a part of it.
You're challenged to. We're gonna take those checks back.
You should be working for this.
Okay, last call. Any questions? All right, it was a great challenge. It was a huge challenge, as you could tell. And they did a good job. There were several teams, they all did well. And then that was just the teams that got invited. Originally, how many teams were?
About 18 originally.
Yeah. And they kind of scoped it down. There was a large group and then they narrowed it down. There was a lab work and then,
Papers and 18.
and then 8 teams came down. We're working with that.
So
So
these all Reese teams? From the college,
well, they have their own company and then Reese and CNA were teamed together. But there were teams from universities, there were teams that were combinations of industry and so it was a mix. And I wouldn't say that it was one size fits all at all.
No, they were from across the US, definitely. Yeah, it was very widespread.
Any last comments?
I would really like to commend ITEC and TEEX for setting up this experiment. It was quite interesting in how disaster study was leveraged and how the data was brought in to MQTT broker and establishing that framework and supporting organized societies. I think they did an excellent job.
We were really excited to be part of such an interactive challenge. It was really, the TEEX facilities outstanding.
And then just one other thing as well, we always enter these competitions because it's a great learning experience. We usually pick something that we have no idea what we're doing. And then it spins off to real work. So this did spin off to real work. So even before we got to the competition, we'd already picked up some clients. So yeah, thank you very much for that. It's great.
And I guess I'll wrap it all up by saying I'm very thankful for Ray and Michael and Walt and all of their work to put together an entire sensor test bed, which they're currently continuing to expand and utilize in their research efforts going forward as well. I think that really all of the teams kind of excelled at different areas in what is an overall very complex problem that has a lot of potential benefits. And I think that we came up with a lot of wonderful outcomes. And we couldn't have done it without the work that you all put into it. So thank you very much. And thank you to everyone in the audience today.
Right.
Okay, before we start the last panel, I want to talk logistics for the Bush Combat Development Complex tour. Okay, this is, we're going to be on an extremely tight schedule, so this is kind of important. So the last panel is going to end at 35 minutes after 3. The tour starts at BCDC at 3:45. That's 10 minutes. Now, it's just like the next building over, okay, but it's a little far to walk. So we're gonna have 3 buses show up. We're maxed out at 99 people. That's because of the size of the bus. So the bus holds 33 people. What we'd like to do is immediately after